Hello everyone. Today's lecture is going to be a review for the topic of database and pandas. I'll be going through the problems in today's lecture worksheet. The link to the worksheet can be found as part of the database 3 entry on the course website. Go ahead and pause the lecture video here and download the docx version of the worksheet in order to follow along. You will also find a code link as part of the same lecture entry. Let me show you the files that are present within the code link. We have two notebook files. The first one is worksheet-answers.ipynb. The second one is worksheet.ipynb. The worksheet notebook file is an interactive version of the PDF or docx worksheet covered as part of today's lecture. I would strongly encourage you to go through the questions using the docx or the PDF version before you move on to the interactive notebook version in order to verify your answers. As all of you might have been able to guess, worksheet-answers.ipynb provides answers to the questions for today's lecture worksheet. All of the tabular data that we'll be using in today's lecture will come from a database called as worksheet.db. You can download the database file from the code link for today's lecture. I've already set up my worksheet over here. Let me quickly give you an overview of the species and trees table which we'll be using for problems 1 through 7. The species table has two different species of trees, which are maple and pine. It also has a code column. The trees table represents individual tree information. All of this data set is inspired from the City of Madison real life data set for trees. The City of Madison maintains a priority ordering for every tree that is managed by the city. What sort of treatment a tree receives depends on its corresponding priority order. Feel free to go through the rest of the columns in the trees table over here. I'm going to talk about the code snippet which we have right here. We are importing the SQLite 3 module. Recall that we've been using the SQLite 3 module in order to run all of our SQLite queries. First thing which we need to do is establish a connection to the database, which is worksheet.db here, and we are going to use the SQLite 3.connect function which returns a connection object. The connection object is captured into a global variable called C. Since it's a global variable, we should be able to use that variable inside a function like query over here. This query function is very similar to the query function which we used as part of the previous lecture on the topic of database. Recall that we've been using the pandas read_SQL function in order to execute a SQL query on a particular connection object. The SQL query itself is passed as an argument to the query function. Examples of SQL query will include select star from species and select star from trees. Each of those queries retrieve the rows within the species table and the rows within the trees table correspondingly. What do you think will be the type of the variables species and trees? Go ahead and pause the lecture video here and write a comment on the comment section stating the type of species and type of trees. If you were thinking those are of type pandas data frame, then you had the correct answer to my question. Why are those data frames? That's because we are using the read SQL function inside the pandas module, and that always returns a pandas data frame. Right. We have two different representation of a data set over here. The first one is the database representation in the form of SQL data. The second representation is the pandas data frame representation. We are going to be switching back and forth between both of those representations, and we are going to convert pandas data frame expression into a SQL query and vice versa. Let's get started by going through problem number 1 over here. Problem number 1 has a lot of square brackets, correct? The technical term associated with using a single symbol to represent multiple meaning is called overloading. So we are overloading the square bracket usage over here. Recall that the very first instance where we started using square bracket was for list creation. We of course can use square bracket for list indexing and also slicing. The second instance where we encountered a square bracket was when using a dictionary. A dictionary lookup also enables us to use a square bracket. The third major category would be pandas, series and data frame. Recall that we have different ways of using square bracket when it comes to pandas. One example of that would be df of x, where you're trying to retrieve the column x by mentioning df of x, correct? I keep pressing my little finger on top of the list of pages, sorry about that. So that gives a column series for us, correct? So excuse my handwriting, trying to write without resting my little finger over here. Alright, so clearly we have a lot of square brackets in this particular question. Let's try to go expression by expression. The first expression is over here when we say trees of priority. So trees of priority is going to retrieve the priority column from the data frame trees. And whenever you retrieve a column or a row in a data frame, you're always going to get a series, right? So you're going to get series of priority column over here. What are we doing with it? We are applying the Boolean condition of greater than 90. So that's going to give us a Boolean series. The Boolean series is going to have false for the first row, true for the second row, false for the third row, false for the fourth row and true for the fifth row over here by applying the condition greater than 90. Once we have the Boolean series, we can take that and reapply that to the original data frame by saying trees of B. What is that going to give us? That's going to give us part of the data frame which is satisfied by that Boolean series. So that's going to give us the rows B and E over here, right? Let me go ahead and write the row index over here. So that's going to be 0, 1, 2, 3 and 4. It starts with a 0 always. And for the purpose of this particular data frame, we are always going to have index and integer possession to be the exact same thing. So once we apply trees of B, we are going to get the values of the rows corresponding to the entry for tree B and E, correct? So that's going to, excuse me, just one second, sorry. That's going to retrieve us the values for the rows B and E over here. But then we don't want all the values of all the columns for those particular rows. We want specific columns of values. How are we mentioning specific columns of values? We have a list over here, correct? How do I know that's a list? That's because there is a comma between the items x and y over here. So it's a list of two string items where you have like first item as x and second item as y. Whenever you apply a list of column names to your data frame, you're going to get a subset of your data frame which only contains those particular column values. Recall that we have gone through similar examples with pandas series. Whenever you apply a list of indices or a list of integer positions, you can just get the corresponding part of those series values. Similarly, when you apply a list of column names to a data frame, you're only going to retrieve those particular column values. So clearly you're going to get the columns of x and y over here. That's what this list represents. So that's going to be x and y, and your corresponding row index is going to be 1 and 4 from the original data frame, and the values themselves are going to be 20 and m and 50 and m. That's just going to be the output of this particular data frame expression over here. Alright, the next part of the question focuses on converting this particular expression into a SQL query. You can think of the Boolean expression condition as the where part of your SQL query, correct? And similarly, you can think of the column selection as select, and the name of the data frame itself is going to be the from part in your SQL query. So the SQL query here is going to be select x comma y from trees where your priority is greater than 90, correct? Alright, let's move on to the next question. The next question is saying select x plus y from trees where species equal to m. So we're only interested in the rows in the trees table where species is m. So I'm circling out all the species column entries where we have a value of m. So you're going to have a subset data frame which only contains rows 0, 1 and 4 over here. What are we trying to compute for those particular rows? We are trying to compute a new column called x plus y over here, right? So that's going to produce a data frame which has the column x plus y, and it has the row index positions as 0, 1 and 4, and the corresponding x plus y value is simply going to be 14, 10 plus 4 14, 20 plus 4 24 and 50 plus 4 54, correct? So when you try to convert this particular expression into pandas, it's not really straightforward to do that. You first need to apply the where condition using a Boolean expression. So you're going to have to say trees of species where you have the condition as equal to m, correct? So trees of species equal to m, don't forget the double equal to, will retrieve a Boolean series for you where species is equal to m. So once you have this Boolean series, you can apply that back to the original data frame. That's going to retrieve subset of the data frame which satisfies this particular condition, right? Let's say that I am trying to capture this data frame into a variable called rows. I just don't want all the column values, but I want to take the column values of x and I want to sum it up with column values of y, correct? So I am going to have to do rows of x plus rows of y over here. Right, let's go through the next problem. The next problem is a little bit complicated because you have various steps over here. So the first step involved in this problem is species of code. So species of code is going to retrieve a column series from the species table. I've just marked that column up on the species table. So the next square brackets applies a Boolean condition where you have species of species equal to maple. So that's going to retrieve a different series for you, correct? So let's first go through the first series over here. That's going to have the values of 0, m and 1, p as corresponding to those entries, correct? Excuse me. Yeah. So you're retrieving the code column value. Sorry, I think I marked the wrong column over here. Let me fix that. I'm interested in the code column, not the species column. My apologies for that. So the first part of this expression is going to retrieve a series which has the entries as m and p, and the corresponding indices are 0 and 1 over here. And the second part, which produces another series, is going to get us the Boolean expressions result, which we get by applying species of species equal to maple. So we are going to get a Boolean expression for the inner part of the second entry over here. So that's going to be this part which I am marking on the top. So that's going to be a Boolean series. So once you have a Boolean series, you can apply it back to the species data frame. So that's going to just retrieve the rows in the original data frame which match the Boolean series condition of species equal to maple, correct? So you're simply going to get a data frame which has the row index of 0 and the corresponding column value of m over here. So now when you're applying the data frame dot ILOC of 0, so that's going to be this last expression over here at the end. So you're going to get the value corresponding to integer position 0, so that's going to be a value m, correct? So you're going to have CD equal to the string m after all of this processing. Alright, let's go through the second line over here. It says trees of species equal to CD. So CD is m. So we're once again interested in rows 0, 1 and 4. But instead of retrieving the entire subset of data frame for those rows, we only want the tree column. So we are going to get the result of this expression as the data frame which has the values for row indexes 0, 1 and 4. Let me follow the same notation over here, excuse me. So I'm going to switch over to my red pen. So my row index positions will be 0, 1 and 4, and my corresponding values for the tree column would be A, B and E over here, right? So I'm going to have A for 0 and B for 1 and E for 4. Right, I'll leave the rest of the SQL conversion as an exercise for you. Let's go through problem number 4. Problem number 4 says select species from trees order by priority descending DESC. Whenever you have a query where you don't have a group by but you have an order by, you're going to take the original rows in the table and you're going to rearrange them in some particular order, correct? What is the order here? You're ordering based on priority in descending order. Let me just write down the priority descending order and the corresponding row indices. So I'm going to say 100 is my first entry and 99 is my second entry. Corresponding row indices are 1 and 4. And then after that you are going to get 71, which is row 0, and then you are going to get 40, which is row 3, and then finally you are going to get row 2, which is 30. So this basically is priority ordered by descending order, correct? So I'm just going to say priority DESC against this. Alright, that gives us the priority order by descending order. What do we need to do the selection though? We are only selecting the species column values. So you're going to have the corresponding values for this particular priority. So you're going to get the values of M, 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 P and P here. Looks like the maple trees are valued more, and the corresponding row index is going to be 1, 4, 0, 3 and 2 over here, and the column name that we are getting is the species column. Right, I'll wrap up this video here. In the next video, we'll go through the next set of problems.